to all my dear residents. Now I am giving a very important question, and that is generally asked in the examination. So I have already told you in alcohol. So what you test for first degree, second degree, third degree alcohol by Victor Meyer's method. Generally asked in examination. And next one is what you see separation of first degree, second degree, third degree amine from the mixture by Hoffmann's method. Yes, from the given mixture. It's very, very important. Generally asked in exam. Out of 2 questions, generally 1 question is generally asked in the examination. So what you see, at first we have to know what is Hoffmann reagent. Means diethyl oxalate. Diethyl. What the formula of diethyl oxalate? COOC2S5CO. H is substituted by ethyl. That is 2-ethyl over graphs. H of the oxalic acid substituted by ethyl. So what the name of this compound? Diethyl oxalate. That is also known as Hoffmann's reagent because it is given by Hoffmann. Yeah, chemist. So first one is, now the given mixture of this first degree, second degree, third degree amine is reacted with diethyl oxalate, yeah, Hoffmann reagent. We get following reactions. Yes, first one we have to see what the reaction with first degree amine. First degree amine, what we know, general formula of first degree amine is RNH2. Example is, you can give any R, methylamine, ethylamine, propylamine. Yes, you can. So what the reaction? That is COOC2S5, COOC2S5. That is diethyl oxalate. So what the reaction over here? 2 molecule primary amine over here, RNH2, RNH2. So one of the H from first amine that reacts with what we see this ethoxide. So what we get? 2 molecule of, how many? 2 molecule of what ethyl alcohol. And what the rest products? CONHR, CONHR. Yes. Next one is CO, what do you see? NHR, CONHR. Yes. Yeah. You can write like this, C double bond NH. You can write C double bond, yes. Better to write structural formula. So that is what you see. What the CONH means amide. So what the name of this compound? How many alkyl over here? 2 alkyls. What we have? Dialkyl oxamide, what see? It is solid state. This derivative is what is solid. Next one is reaction with secondary amines. You know, general formula of secondary amine is RNH. You know, 2R over here. What the example of this one? CH3N, CH3. How many methyl? 2 methyl. So what we can write? Dimethyl, what to see? Amine. Yes. So now this secondary amine that when reacted with what? So how many H over here? 1 H. So one of the H reacts with this ethoxide. So what we have? And what we get? Double bond. Yes, better to write this one. Yes. So what we get? This is react with H, and what we get? 1 molecule of ethyl alcohol, and what the rest of CONRR, CONRR. If you practice by writing, you have never problem, never. So learn by what you see, learn by heart. Yes. So what you see, this when treated with secondary amine. So what we have? So this product we get. So what how many alkyl group we have? 2 alkyls. What we have? Dialkyl oxamic ester, because ester group over here, and it is liquid derivative. Yes, first one is solid derivative, second one is liquid derivative. Yeah, third one is reaction with third degree amine. What the general formula? N3R over here. So example is like this: CH3N, 3 methyl over here. Yeah, we can give any. So better to better to give 1 alkyl group similar. So how many methyl? Trimethyl amine. Yes. So now this is treated with diethyl oxalate. So what we have? In this case, what we see? N has no any H, hydrogen atom. So it does not react with what we see, diethyl oxalate. So what we get? It has no reaction. Why? Because it has no hydrogen in nitrogen atom. Yes. So what we see over here in first derivative, in first degree amine, what you get? Solid derivative. What the name of this compound? Trialkyl oxamide, solid derivative. With secondary amine, what to get? Dialkyl, what to see? Oxyamic ester, that is liquid derivative. Third one, what to see? There is no reaction over here. So at first, we have to remove this, what to see? Third degree, what to say? That is the third degree amine. So at first we have to remove from the mixture third degree amine. Why? From the mixture by fractional distillation, because its boiling point is very low, so we can remove it easily. So at first remove this third degree amine. Then what we have? What to see? Dialkyl oxamide and what to see? Dialkyl oxamic ester. Now we have to treat both derivative with boiled with what to see? Potassium hydroxide. So yes, look at over here. So we have already what to see? Remove the third degree amine from the what to see? Mixture. How? By fractional distillation. Why? Because its boiling point is very low. Now the remaining one is solid derivative of primary amine and liquid derivative of what to see? Secondary amine. So what we have to do? So we have to do filtration. So after filtration, what to get as a residue? As a residue, what to get? What to say? Dialkyl oxamide. And as a filtrate, what to get? What to get? Dialkyl oxamic ester. Yes. So that is the solid portion, that is the liquid portion. Yes. So both portion, solid derivative and liquid derivatives, are boiled with potassium hydroxide. So what to get? In first case, solid derivative, what to get? Potassium oxalate and 2 molecules of what we see? Primary amine. Why? Because in this case 2 molecules of primary amine involved in the what we see? Derivative. Yes. With the secondary derivative, second what we say? Dialkyl oxamic ester, what do we have? So in this case only 1 molecule involved in the reaction. So when that is boiled with potassium hydroxide solution, so what to get? Major product is potassium oxalate, but what we need? Secondary amine. So how many molecules we get over here? 1 molecule. Why? Because only 1 molecule of secondary amine involves in the reaction. And what the side product? C2H5OH. So we have already what to say? Extracted, isolated what to say? Primary amine from the mixture, from the solid derivative. Now from the liquid derivative, we can separate what to see? Secondary amine as well as what to see? Ethanol, we can say, that is ethanol. So we can remove, we can isolate it, we can extract it by fractional distillation. So after fractional distillation, what we get? One portion is secondary amine and another portion is what we see? Ethanol. So by this method, we can separate first degree, secondary and third degree amine from the given mixture by Hoffmann's methods. Very, very important. Thank you for watching this video.